Testing the sound. Statistics students, we're taking a look at Chapter 2, Problem 63, and I loaded the data set in our Canvas page. If you scroll all the way down, you're going to see Chapter 2 data sets, and here's our Shark Tank text. Open that up. And you can copy and paste this over into the applet. I've already done that, and as we did earlier in class, we created a histogram. We saw that the mean was 15.59, and the standard deviation is 2.55. So I'm going to go ahead and shift to my Word document at this point. I've created my histogram, and I'm recognizing I forgot one little bar here. Okay, and I may have missed one more, so just grab it. Let's see, 7. Yep, I forgot one more there. Alright, so this was with our socks. The shape was slightly right skewed. We had an outlier of 22.8. We have a center where the mean is 15.59 and the median is 15.75. So those are really close together. It's looking like we are symmetric. The spread has a standard deviation of 2.55, and that's a moderate spread. So then I looked at letter B a little bit more. With letter B, I drew my bell curve and just kind of cleaned it up a little bit. Now here is where we left off in class. The book asks us to find the percent of the data that is within one standard deviation. So I took my mean, and I added and subtracted one standard deviation from that. And I came up with the values of 13.04 and 18.14. I did that with adding and subtracting 2 standard deviations. And then I added and subtracted 3 standard deviations. Let's go back up to that first standard deviation. So, of all the data that should fit within one standard deviation, it is going to be sharks of length 13.04 feet up to sharks with 18.14 feet. If I look back at my original data, and I find that 13.04 is my cutoff on the low end, and then I find on my high end 18.14, all of the highlighted numbers are within one standard deviation, which is a lot. If I add up, not the numbers, but just count how many are highlighted there, there's 30 that are highlighted. If I do that for 2 standard deviations, it's between 10.49, so less than 12, and then it goes to 20.69. I can see that it's all the data except for this really tall shark or long shark and this shorter shark. That means 42 of the 44 are within 2 standard deviations. And if I go within 3 standard deviations, it happens to be all of those. So 44 out of 44. Let's go back to my document. So the number of sharks between 13.04 and 18.14 feet were 30 out of 44, which is 68%. And for 2 standard deviations, the sharks between 10.49 feet and 20.69 feet were 42 out of 44, or 95%. I calculated that. I took 42 and I divided it by 44, and I got 95. And then of all of the shark's 3 standard deviations above and below the mean. It's 44 out of 44, so we have 100% of our data there. That means the shark data is distributed just like the 68-95 99.7 rule, with the exception that the 99.7 is actually 100% of our data. We can see 68 was 30 out of 44, 95 was 42 out of 44, and 100% was 44 out of 44. Letter C talks about a, asks us is, let me pause here. Okay, I had to refresh what the next question asked. It asked about a normal probability plot. So I took all of the data and I found a calculator online that allows me to dump all the numbers right here. I pasted all those numbers into it and it creates a normal probability plot. I do not want you to know what a normal, like how to create a normal probability plot. I just want you to paste the data into a website. Hopefully Prosser doesn't block too many of those websites, but it might. Anyways, you're going to go ahead and you're going to scroll down and you're going to look at your plot once you've got all your data in there. And I just copy and pasted it. So here's my plot. And I can see that this is fairly linear. I could draw a line through here fairly easier. And because it is modeling a straight line, I can say that this plot is linear enough that we can say we probably have a normal distribution. So that's what I wrote on C. I wrote the plot is linear enough that we can say lengths are normally distributed. And then D wanted us to use all the parts A, B, and C and say, is this normal or not? So I said, the histogram was fairly normal. We found that shape, center, and spread as being fairly normal, with the mean and median really close together. Then we noticed that our data, when we actually figured out how many are 1, 2, and 3 standard deviations away from the mean, matched the 68, 95, 100 rule. And with the normal probability plot that the internet can create for me, I saw that it was linear. And I can overall then say that our data is normally distributed. If you are looking at a normal probability plot, such as this, and it is not a straight line, then we would say our data is not normal. I hope that helps.